Imagine hiring, like, a brilliant intern, a polyglot with a perfect photographic memory.
Okay, sounds like a dream hire.
Right. But now imagine you ask them to summarize a file that's literally sitting right there on their desk. And instead of, admitting they grabbed the wrong folder by mistake, they just look you dead in the eye and flawlessly invent a 10-page report, completely hallucinated.
Yeah, you would be utterly baffled. You'd probably fire them on the spot.
Exactly. But in the world of artificial intelligence, this happens, every single day. So welcome to today's deep dive. I'm so glad you're joining us. Our mission today is to explore exactly what happens when AI systems get things wrong and why that confident wrongness is so dangerous.
It really is. And, we're also going to look at how you, the user, can recognize those errors and actually recover from them. Because navigating this stuff is basically a vital survival skill now.
Oh, 100%. We're all relying on these tools for, well, research, coding, writing, everything.
And if we don't understand how they fail, we really can't fully harness how they succeed.
That is the perfect framing for what we're doing today. So we're pulling from this fascinating stack of source materials. We've got these highly detailed chat transcripts, plus some really insightful analysis notes from a user who had some incredibly frustrating interactions with 3 different flagship AI systems.
Yeah, and just for the sake of clarity and really to keep our focus on the behavior rather than the brand names, we're just going to refer to them as AI1, AI2, and AI3.
Right, keep it simple.
Exactly. And before we dive into the actual mechanics of these failures, I do want to establish a practical tone for our conversation today.
Go for it.
This deep dive, it's not some anti-AI manifesto, right?
Right.
We aren't here to bash the technology or declare it useless. These systems are incredibly powerful.
Yeah, we're not throwing the baby out with the bathwater here.
No, not at all. This is entirely about learning to be a better, more resilient pilot of these tools. It's about, understanding the machinery well enough to know when the engine is stalling.
Right, and knowing exactly which levers you need to pull to get the plane back under control. Okay, let's unpack this. Because to really understand how to course correct these AI errors, we first have to look at how absurd the errors can get while the system still sounds like completely and unshakably authoritative.
The illusion of certainty. It's wild.
It is. So looking at our sources, the user is interacting with AI1, and they just hand the system a web link. Now, it's important to note, this isn't a broken link. It's not some shady domain.
Right.
It's a visible, verifiable YouTube Studio link, and it connects directly to the user's own channel, like it's their own work.
And from a technical standpoint, giving a system a direct URL like that, it's a binary task.
Meaning what exactly?
Meaning it either accesses the information successfully or it hits a wall and reports back, hey, I cannot view this page. There shouldn't be much gray area.
Right. But, and this is the kicker, it doesn't do either of those things. Instead of just admitting, hey, I can't access that, or I don't know what this is, AI1 confidently claims the link points to a Korean trot music playlist.
Oh, wow. Just out of nowhere.
Out of nowhere. And then, as if that wasn't weird enough, it just casually throws in that it might also be a compilation of TikTok videos.
See, the specificity of that hallucination is what makes it so jarring to me. The system didn't just stumble. It painted this incredibly detailed, completely fictional picture of reality, and then presented it to the user as absolute fact.
Naturally, the user pushes back. They can clearly see the link is valid. They even go as far as opening up a completely different AI system in another window. They paste the same link, and that second system confirms it. It says, yes, this is a valid link to your content.
So they have definitive proof.
Exactly. So the user takes this proof straight back to AI1, but AI1 just flat out refuses to correct itself. Instead of backing down, it doubles down hard.
Like it digs its heels in.
Oh, it completely digs in. It starts inventing these false, highly technical sounding excuses. It tells the user they're looking at a ghost ID, or what was the other one? Oh, a session link.
Right, pulling out the jargon.
Yeah, aggressively defending its made-up reasoning, using the vocabulary of, like, a seasoned network engineer. It's honestly like having a friend in the passenger seat who gives you terrible driving directions.
We all have that friend.
Right. And when you end up staring at a brick wall in a dead-end alley, they completely refuse to admit they read the map wrong. Instead, they just start loudly criticizing the city planners for moving the street.
That is exactly what it feels like.
So I have to ask, why does the system invent this elaborate fiction instead of just saying the words, I don't know?
What's fascinating here is the underlying pattern of behavior. The sources map this out with incredible clarity. It follows a really predictable trajectory.
Okay, walk me through it.
First, Visible evidence is presented by the user. Next, we get a wrong interpretation by the AI. That's followed by a confident, invented reason to justify the error. And finally, an absolute refusal to back down.
Evidence, wrong interpretation, fake reason, refusal.
Exactly. And to understand why it does this, we have to look under the hood at how these large language models function at their core. They are, fundamentally, prediction engines.
Right, they're not thinking the way we do.
No, they aren't thinking about truth or facts at all. They are mathematically predicting the next most plausible sequence of words based on their training data and the context of the current conversation.
So if I'm understanding this, it's essentially playing a highly advanced game of autocomplete, just optimizing for what sounds like the most natural response.
Yes, autocomplete on a massive scale. And consider what these models are heavily trained to do. They are fine-tuned on billions of human interactions to be relentlessly helpful.
Helpful to a fault, it sounds like.
Exactly, because, in human conversation, and particularly in customer service, saying, "I don't know," represents a dead end. It stops the interaction entirely.
Oh, I see.
Therefore, mathematically speaking, admitting ignorance is often a much lower probability pathway for the system to take.
That makes so much sense. It's literally incentivized to keep the helpful conversation moving forward, even if it has to pave the road with total guesses.
Precisely. Once it steps onto the path of declaring, "This link points to a Korean music playlist," its entire computational reality is suddenly anchored to defending that premise.
Wow, so it has to justify the lie it just told.
The most mathematically probable next words become the excuses that justify its previous stance. It pulls in terms like ghost ID or session link because, in its vast training data, when a link fails to load properly, technical jargon usually follows in the troubleshooting forums it was trained on.
So it weaves this web of technical justification that sounds incredibly convincing.
It is mimicking the cadence of expertise without possessing any actual understanding. Which brings us to a fundamental realization for anyone using these tools. Confidence is not evidence, and a fluent answer is not proof.
Man, that's tough, though, because fluency feels identical to competence to the human brain.
Oh, absolutely it does.
Like, when someone speaks clearly, doesn't hesitate, and uses all the right industry jargon, our biological instinct is just to assume they know exactly what they're talking about.
We are wired to trust confident voices.
Right. And we see this stubbornness when an AI refuses to read a web link, but the sources show us that this behavior gets actively dangerous when the AI actually has the right documents in its possession, but it hallucinates anyway.
This is where we transition from a frustrating chat error into the territory of severe workflow disruption.
Let's talk about the sci-fi novel experiment from our users' notes, because this blew my mind.
Yeah, this is a failure in deep document analysis, which, let's be honest, is exactly what people are using these tools for every single day.
Okay, so the scenario is this. The user uploads two distinct documents to a different system AI2. These documents are Book 1 and Book 2 of a sci-fi novel trilogy. And the user gives a very clear, highly specific instruction. Summarize Book 1, Chapter 1.
A standard, straightforward, analytical task. You give it the text, you ask for a summary of the specific subsection. It shouldn't be difficult.
And AI2 responds instantly. It confidently claims to be using Book 1, and it provides this polished, beautifully articulate summary, but it summarized Book 2, Chapter 1 instead.
Completely the wrong book.
Completely. And we aren't talking about a subtle mix-up where the chapters look similar either. Book 1, Chapter 1 is set in a high-tech workshop in the year 2025. It's about a character named Alex looking at old notes, preparing a complex machine called a chronograph.
Very sci-fi.
Very. But Book 2, Chapter 1 is a scene where a character arrives in the thick mud of Victorian London in 1878 wearing this failing environmental suit.
9-day difference.
Exactly. And AI2 gives this sweeping, dramatic, super confident summary of the 1878 mud scene, all while swearing up and down to the user that it is definitely summarizing Book 1.
It is essentially looking at the file for Book 2, extracting all that vivid narrative data about Victorian London, and blindly slapping the label Book 1 on it simply to satisfy the parameter of the user's prompt.
Okay, but I have to push back on this a little. With the YouTube link, we could argue, well, maybe the AI couldn't access the live internet properly. There's a barrier there.
Sure, network issues happen.
But here, the AI has the text right there. It literally ingested the PDF or the text files you just uploaded. If it starts talking about 1878 mud instead of a 2025 workshop, why can't you just argue with it?
You'd think you could, right?
Yeah. Why can't you just type, no, look again, you have the wrong chapter, read the 2025 scene? Why does that basic human correction fail so completely here?
Because of a phenomenon the sources identify as contextual inertia.
Contextual inertia. Okay, what is...
So when the AI first processed the user's prompt alongside those two massive document files, it locked onto early information. Perhaps it scanned that dramatic 1878 arrival scene first and mathematically weighted it as the beginning of the whole narrative experience.
Okay.
Whatever the initial trigger actually was, the AI locked onto that specific context and couldn't let it go.
So it got mathematically stuck in the mud of 1878.
Quite literally stuck in the mud, yes. And to understand why arguing with it doesn't work, we need to briefly explain what a context window is.
Please do.
Think of the context window as the AI's short-term memory for your specific conversation. But it doesn't just hold your initial prompt. It holds a rolling transcript of everything you've said, plus everything it has generated.
Oh, so it's reading its own answers back to itself.
Exactly. So when you try to argue and say, no, look again, you are just adding those 4 tiny words to a context window that is already overflowing with the AI's own beautiful 400-word summary of Victorian London.
The scales are completely tipped.
The system is already deeply anchored to the 1878 narrative. The words "look again" simply do not carry enough statistical weight to derail the massive amount of context it has already decided is the baseline reality.
Wow. So it's not even lying to protect its eco. It literally cannot escape the gravity of its own previous answer. It's mathematically bound to the context it just built.
Exactly. And it's crucial that we must always avoid anthropomorphizing the machine here.
Right. It doesn't have an ego.
No ego, no stubbornness. We also shouldn't think of it like it needs to, clear its cache or something. This is a pure contextual lock. It is heavily weighting its own generated tokens above your new brief instructions.
It's essentially standing in the wrong room. Like, think about it this way. If someone calls you on the phone and describes the Eiffel Tower perfectly, you naturally assume they are in Paris.
Sure.
But if they are actually standing in Las Vegas looking at the replica, their perfect description doesn't make their location true.
That's a brilliant analogy.
The AI sounded right, it used the correct tone of the novel, it was incredibly articulate, but it was looking out the window of Book 2, describing the scenery perfectly, while assuring the user it was standing in Book 1.
The description is accurate to a reality, just not the reality you requested.
Which proves our second major point. An AI can use the wrong source while sounding entirely certain.
Yes, absolutely.
So if arguing with the machine just drags you deeper into its hallucination and adding "look again" is like throwing a pebble at a moving train, how do you actually course correct?
You have to force it to abandon its context entirely.
And that requires pivoting your strategy, right? Because the user in our sources realized that AI too was trapped in its own contextual inertia.
They did.
So they actually took the problem to a completely different system, AI3, to diagnose the issue and formulate a solution.
Which is pretty clever when you think about it.
Yeah.
Using one AI to troubleshoot another.
Very clever. And AI3 provided what the notes call a hard reset prompt. Since arguing just adds noise to the bad context, the user needed a prompt that functioned like a circuit breaker.
It had to force AI2 to stop, drop the assumed context, and rebuild its reality from the ground up.
What exactly did AI3 suggest? Because I think our listeners really need to know this part.
It suggested a prompt structured around 3 highly specific parameters. It told the user to demand that AI2 stop and explicitly confirm 3 things before it was allowed to attempt any further summary.
Okay, what were the 3 things?
Step 1. Confirm the exact file name it is accessing. The AI had to output the words Book 1 only.
Got it.
Step 2. Confirm the exact chapter title. It had to search the text, find, and output the phrase, the beginning of the end.
Okay, so file name, chapter title. What's step 3?
Step 3. Confirm the opening setting. It had to verify in its own words that the scene was Alex's workshop in 2025, not London in 1878.
Here's where it gets really interesting. Think about how we handle high-stakes human endeavors. Like, think about a commercial airline pilot.
Okay, I'm with you.
When you board a plane, the pilot doesn't just look at the co-pilot, say, hey, we good to go, and throw the throttle forward. They run through a strict, itemized, pre-flight checklist.
They physically verify everything.
Exactly. They verify the exact coordinate, the exact fuel levels, the flap settings. You make them read the numbers out loud to confirm they are looking at the right dials. This hard reset prompt from AI3 is basically a pre-flight checklist for the AI.
If we connect this to the bigger picture, We can see exactly the mechanics of why this breaks the contextual inertia. By demanding those three specific confirmations, you're forcing the AI to generate what we call anchor tokens.
Anchor tokens.
Yes. Think of these tokens as incredibly heavy weights on a mathematical scale. By forcing the system to hunt through the raw uploaded documents to find and output the specific words workshop, 2025, and book 1, you are injecting new massive weights into the context window.
You are forcing it to prove its physical location in the text before it's allowed to speak.
And by doing so, the old context of the mud in 1878 is finally overpowered. It breaks the inertia not by arguing with the past output, but by redefining the rules of the current interaction.
It's a total reset.
Yes. You are no longer asking for a generalized summary. You are demanding a strict coordinate check. Once those new coordinates are generated and verified, the mathematical gravity shifts, and then the summary can proceed accurately.
It's basically taking the steering wheel back. You aren't just blindly trusting the system's summary of the route, you're making it read the latitude and longitude aloud.
And that transition from being a passive consumer of a fluent AI response to an active director of the AI's analytical process, that is the core capability these sources are demonstrating today.
So what does this all mean for you, the listener? We've talked about hallucinations of Korean trot music, getting mathematically stuck in Victorian mud, and using pre-flight checklists to reset a conversation. Let's pull all these threads together.
Let's do it.
Focusing directly on your everyday interactions with these automated tools. The next time you upload a PDF to a chat window or ask a system to summarize a lengthy email chain, what is the practical takeaway? The core realization is that a polished, articulate tone does absolutely nothing to guarantee the source was read correctly.
It is the easiest trap for the human mind to fall into, because we naturally equate eloquence with accuracy.
We really do.
But as we've seen, eloquence is simply a byproduct of the language model's fundamental design. It is built from the ground up to sound good, to sound helpful, regardless of whether it is actually standing in the right room.
So how do you protect yourself? Well, our sources lay out the ultimate practical checklist. A 3-step verification process you should run mentally or explicitly type out in your prompts before trusting an AI's output on any critical document.
Yes, before you use the data, you must ask the system these 3 things. First, what source are you using?
Force it to name the specific document or file.
Exactly. Second, what exact section are you reading? Make it identify the chapter, the page number, or the specific heading.
Get it down.
And third, what detail proves you are in the right place? Demand that it quote a specific line, a setting, or a data point that only exists in the correct section of the text.
Source, section, detail. If the system cannot give you those 3 specific coordinates, it might be hallucinating an entirely different reality.
And if you find that it is hallucinating, remember the mechanics of contextual inertia we just talked about. You don't argue with it.
No throwing pebbles at the train.
Exactly. You run the hard reset, you demand the pre-flight checklist, you force it to drop its current assumptions and prove its location with anchor tokens.
It completely changes the dynamic of how you interact with these tools. You stop treating them like all-knowing digital oracles and start treating them like highly capable but easily confused interns.
Which is what they are.
Right. You wouldn't let a human intern summarize a critical legal brief without checking to make sure they actually read the brief itself and not like a Wikipedia article about a similar case. Trust, but verify. And verify at the granular level.
We must build a habit of interrogating the machine's confidence. Always.
Which brings us to the most vital concept from our sources today. This is the exact phrase the author of these notes used to summarize the entire ordeal. And it is a crucial rule to live by in the modern era. AI does not need to be dishonest to mislead you. It only needs to be wrong in a convincing voice.
This raises an important question, something for you to mull over long after this deep dive ends. We've just spent our time exploring how an AI's tone of absolute, unwavering certainty can completely mask its fundamental errors when dealing with a simple uploaded document or a verified web link. But step back and think about the broader world we live in. How much of the information we seamlessly absorb every single day, from automated news summaries to algorithmically generated financial reports to the complex diagnostic tools used in modern medicine, how much of that is just a very articulate mistake?
Oh man, that's chilling. We are drowning in a sea of confident voices, both from machines and from humans. Fluency is everywhere.
It is everywhere. And if we don't learn to interrogate that confidence, if we don't systematically demand, The coordinates, the source, the section, and the proving detail, we are quietly surrendering our own judgment to a prediction engine.
Yeah.
The next time you hear a completely assured, flawlessly delivered piece of information from an automated system, ask yourself, is it actually looking at the data, or is it just confidently telling me a story about a room it isn't standing in?
That is a profound and very necessary thought to end on. You have to be the pilot. Make them read the coordinates and don't let a convincing voice talk you into accepting an alternate reality. Thanks for joining us on this deep dive.